Let's take a look at logic blocks. So here we have a range of different types of logic blocks that we've seen. And the question is, which of the following logic blocks here have to convert between binary and one hot? There may be more than one answer. So let's go through these. So a mux takes in a bunch of inputs and chooses one of the outputs. And what it does, it uses a binary selection signal to choose from the one hot input, choose a one hot input to output. So it's using this binary input in order to choose one of these inputs. So it's definitely doing that. A demux, it does the opposite. It uses its binary input to send this one input to one of those outputs. So that's a one hot output. So we're using a binary select for the input to send it to the output. An encoder takes in a value here, a one hot input, and converts it to a binary output. So it's certainly doing the conversion. And a decoder does the opposite, takes in a binary input and converts it to a one hot output. So all of these are doing a conversion between binary and one hot. How about an adder? Well, here's our typical adder circuit, and we notice it has two inputs and two outputs here. And what it's doing is taking A and B as the input, adding them up and generating a sum output and a carry output. And we want to have a bigger adder, we put that carry output into the carry input on the next one, and we chain the adders together. But there's nothing in here that's taking a binary value and converting it to a one hot value. Here's a practice about logic blocks. So we've got a circuit here. If you look at the circuit, it's got an encoder, a decoder, and some muxes. And the question is, for these various inputs here, what is the output for each of those, and how would you describe what the block does? Now note, I've labeled here what the most significant bit and the least significant bit of the inputs are, so you can tell for these values. Okay, so let's walk through what happens here. So this encoder is going to convert this one hot input into a binary value, and this decoder is going to convert that same binary value back to a one hot output. So what we're going to see here is we're going to take a one hot value here, convert it into binary, and convert it back to one hot. So this output is going to be the same as the input. We look at the top up here, this demux is going to take the input and send it to one of these four wires, and this mux is going to take one of those four wires and send it to the output. Since these are both using the same select lines here, the input is going to be the same as the output. So it's just going to pass it through. So this seems like a pretty foolish circuit. It's just going to get the same results in the output that it does in the input, but it's doing it in a remarkably complicated manner. All right, so let's try this out. So here's the first value here, 1001. Let's see what happens. So here's our input, most significant bit 1000, and our least significant bit 1 is going in over here. So our encoder is 1 hot, so this is a 3 and 1 hot, so it's going to output a 1 1 here. So we're going to send 1 1 along these wires. Both of them are going to be true. Now, this demux is getting an input of 1 1, so it's going to select output 3. So it's going to take that 1, it's going to send it to output 3. This 1 is now going to be on this wire. Now this same 1 1 here goes along these wires, and we're going to go along here to the mux. And the mux is going to take input 3 and send it to the output. So we're going to get a 1 on the output. Similarly, the decoder here takes in a binary 1 1 as its input, and it's going to go and convert that into a 1 hot 1000 as the output. So what we see is we get the same output here, same as the input. So if we have this input here, we get the same thing for the output. And it's going to be the same way for the next one. Here all we've done is change the 0 on the least significant bit, so we change this to be a 0, but it's still going to flow through. Now we can take a look at the other one here. So this is 001. So if we go through here and we have 1 in that, this is 1 hot 0, so the binary output is going to be 0 0. Binary output of 0 0 is going to cause us to choose output 0 here. Going to send a 1 along this wire. The 0 0 is going to cause the mux to choose that input and send it to the output, so we're going to get the same thing on the output. And similarly, the decoder here is going to take in the 0 0 and convert it into a 001 as 1 hot. So again, we get the same output as the input here, and we'll do the same thing there. Now, question is, what happens with this input? So for the last input here, let's take a look at what happens. So we've got 1110 here, but this is not a valid 1 hot value. So what is the encoder going to do as the output here? Well, we have no idea. It's going to generate something, but we don't know what that is. Now, what's the demux going to do? Well, we don't know what the input selected here, so we don't know which output it's going to use. Also over here, we don't know what these values are going to be, so we don't know what input mux is going to choose, but it's going to be the same one as demux. These are both getting the same binary value here. This is a binary value because these wires can only be 1s and 0s, so there is a 1 and 0 value here. So this is going to be the same thing going through here, but we don't know which of these wires it's going to take. So we're going to get the same thing out for the least significant bit. But if you look down what's happening here, we don't know what the input here is, so we don't know what the output is going to be. This is a binary value, but it's a binary value of 2 bits. So we can't have a very large number coming out of here, and there's no reason to believe it's going to be the same one as here because we haven't been able to encode this correctly. So we don't know what the output's going to be here. So the results we're going to get are something, we don't know what it is, and a 0 at the end. All right, so what does this block do? Well, the output is the same with the input if the 4 most significant bits are 1 hot, otherwise it's undefined.